Assalamualaikum warahmatullahi wabarakatuh. In this video, I will proceed with a complex zero solver polynomial function, which is subtopic 3.5. Conjugate pairs zeros theorem. So this theorem says that if there is a complex number z is equivalent to a plus bi, which is a zero of a polynomial, then its conjugate, which is denoted as z bar, is equivalent to a minus bi, is also a zero of bx. So let's look at to the first example here. Find a polynomial px of degree 4 that has a real coefficient and zeros 2i and 4i. So what we have to do here is, since we know 2 of the zeros, which is 2i, automatically negative 2i is also the zeros. And given also 4i is the zeros, automatically negative 4i, which is the conjugate, is also a zeros of a polynomial. So what we have to do with all these zeros, so as usual when we try to construct polynomial function, in general we have a x minus r1, so with the degree of 4, x minus r2, x minus r3, and times with the x minus r4. So when there is no information given, we will assume the leading coefficient a is equivalent to 1. So in this case, we assume a is equivalent to 1. Therefore, px is equivalent to x minus with the 2i, and then x minus with the minus 2i, and then x minus with the 4i, and x minus with the minus 4i. So when we open the bracket, so you will get x minus 2i, x plus 2i, x minus 4i, and also x plus 4i. So what we have to do for you to get the polynomial function with the degree of 4, so you have to expand everything. So when you expand this one, you will get x squared, and then minus 4i squared times with the x squared minus with the 16i squared. So I squared we have learned in chapter 1 is equivalent to negative 1. So substitute with the negative 1. So you will get here x squared minus, so we have here x squared minus 4 times with the negative 1, and then times with the x squared minus with the 16 times with the negative 1. So you will get here x squared plus 4 times with the x squared plus 16. Then you expand this expression, so you will get at the end in general form, the polynomial px is equivalent to x squared plus with the 20x and then plus with the 64. So make sure leave your answer in general form. So this one should be x power of 4, this one should be 20x squared. So this is the final answer, x power of 4 plus 20x squared plus 64. Now let's look at to this example 2. Given 1 plus 4i is one of the complex zeros of the polynomial of x power of 4 minus 5x cubed plus 5x squared minus 15x minus 306. So we need to use theorem on conjugate pair zeros polynomial. So from here what you will get, so we have a plus 4i given as a polynomial, and as a zeros of a polynomial, automatically the conjugate, which is 1 minus 4i, is also the zeros. So what we have to do with these two zeros given, so even though only one of the complex zeros given, by using the theorem on conjugate pair zeros polynomial, so 1 minus 4i, which is the conjugate, is also the zeros. So we need to find out another two factor. So this one we already have two zeros. So since the degree of polynomial is degree of 4, so we need to get the remaining two zeros. And these two zeros, we do not know whether it is a complex zeros or a real zeros. So that is your task to get the another two zeros. Then you can identify whether it is a real zeros or a complex zeros. Okay, so what we have to do with the two zeros given, we can make use that complex zeros as a divisor of the polynomial, because this one we know that this is a factor because it is a zeros of a polynomial. So when you try to construct that one in terms of divisor, so we can get x minus with the 1 plus 4i, and then x minus with the 1 minus with the 4i. So when you expand this expression, so you will get here x minus 1. So we will put together that x minus 1, so that will be easier for you to expand later. So minus with the 4i, and then x minus 1, and then plus 4i. So you can also expand directly from this expression, but it will be more easier if you put together that x minus 1, so that you can see clearly. We can assume this one as your a, this one as b, this one as a, this one as b. So it is in the form of a minus b and a plus b, and we know that when we have these two factors, when you expand, you will just get a squared minus with b squared. So that's why we have to put in this form. So we can just use this formula. So when you expand, so you will get x minus 1, which is your a squared, and then minus your b squared is 4i squared outside the bracket. Then when you expand x minus 1 squared, so you will get x squared minus with the 2x plus 1, and then minus with the 16i squared. So 16i squared we can substitute with the I squared, we can substitute with the negative 1. Therefore, you will get at the end the divisor is x squared minus 2x and then plus 17. So this term comes from the two of the zeros of this polynomial. Two of the complex zeros that we get here, we can make this term become divisor of this polynomial. So since it is the divisor and it is also comes from the zeros, so it is a factor. So what you have to do with this divisor, we can use long division to get another two zeros. So by using long division, so let's apply long division here. So we have x power of 4 minus with the 5x cubed plus with the 5x squared minus with the 15x minus with the 206. And then by using long division, we have the divisor here is x squared minus 2x plus 17. So what is the values of the remainder that you should get here? So you should get the remainder as 0, because the divisor that you use here is a factor of the polynomial function. So you have to apply long division, make sure it is a correct long division. So when you apply long division here, so the first step, you want to remove the x power of 4. So hopefully you will still remember how to apply long division. So in order for you to remove the x power of 4, we need to have x squared here. So x squared, x power of 4. So multiply x squared with everything. So you will get minus 2x cubed. And then we have here plus 17x squared. Then we have the operation of minus here. So minus, so you will get minus 3x cubed. And then this one you will get minus with the 12x squared. Then we have to bring this down, so we have negative 15x. And then we have here negative 3x. For you to remove negative 3x cubed, so 3x cubed, negative 3x cubed plus 6x squared. And then we have minus with the 51x. So the operation here minus. And then we have here negative 18x squared. This one is plus 36x, and we have to bring this down, so we have minus 306. Then we need to remove the term of negative 18x squared. So we have to have up here negative 18, so that we can remove negative x squared. Then plus 36x minus 306. At the end, the remainder here should be 0. So this is our quotient, the terms of our quotient. And what we have to do when we try to rearrange this polynomial, so in general, we have the polynomial which is px is equivalent to qx that we get here, which is x squared minus 3x minus 18. So this is our quotient times with the divisor just now is x squared minus 2x plus 17. So it's up to you whether you want to put divisor first or you want to put quotient first. So for this one is, we know that from this quadratic you will get two of the zeros, which is a complex zeros, 1 plus 4i, and its conjugate, which is 1 minus 4i. So the question here is find all the zeros. So one of the zeros we know that should be 1 minus 4i. So 1 minus 4i is the remaining zeros other than 1 plus 4i. And another two zeros comes from this quotient. So what you have to do with that quotient, you have to factorize completely. So you will get here equivalent to, so factorize this quadratic, so you will get x minus 6 and x plus 3. So this one is x squared minus 2x plus 17. So make sure you go back to the question. What is the question ask you to find out? So find all the zeros of polynomial. Therefore the zeros are, which is including the remaining zeros, come from the conjugate, which is 1 minus 4i. And then another two zeros comes from this two linear factor, which is 6 and also negative 3. So you should have these three zeros in your final answer as your solution. So this is your final answer, 1 minus 4i, 6 and also negative 3. Okay, so let's look at to this one. So I will guide you for the first two questions maybe. Okay, so find the maximum number of zeros of Px. So we have found this kind of question in the previous subtopic. So the maximum number of zeros depends on the degree of the polynomial or the higher degree of that polynomial. So in this case, the higher degree is 3. Therefore, the maximum number of zeros should be 3. And then by using this discard rule of sign, we need to find out how many variation in sign for the positive. So this one, there are 3 variation. Therefore, the possible positive real zeros, so it's either 3 or 1 positive real zeros. And how about the negative real zeros? So you have to substitute x with the negative x. So p negative x, so you will get negative x cubed, and then minus 9x squared minus 17x minus 21. So in this case, there is no variation in sign. So we can conclude that there is no negative real zeros. So it is not necessary for all the polynomial function should have positive or negative real zeros. So if there is no variation, meaning that there is no positive or negative real zeros. So I think that's all. So you can proceed with exercise 1 and also exercise 2. So we will discuss in class. Okay, thank you.